Good afternoon, everyone. Thank you for joining me again on this beautiful Thursday, at least here where I'm at in Maryland. It's very lovely out today. And as always, I'm Clark, and I'm the graph guy. So, as usual, some quick housekeeping and administrative type notes. Still chasing that follower goal, so please follow if you haven't already. Ask other people to come join us. You can as well. Always go to Graph Guy to our video to our I can't use words today. Can't to our website. So graphguy.com. Here it is. You can go there and get information about our past episodes as well as links to the videos for that. So if you miss an episode, you want to go back and reference it, Graph Guy is definitely the place to go. Excuse me, apologies ahead of time. My seasonal allergies have kicked in a bit today, so we will struggle through that. We're coming up on the holidays, obviously, as well. So the next 2 weeks, there will not be a live Graph Guy. We may stream a repeat, but I'm actually going to be headed off on vacation starting next Thursday. We'll be gone for about a little over a week. And there's Puppy. So let's see if we can. So yeah, next 2 weeks, no live Graph Guy. Keep an eye on the Twitter feed. It is possible that we will stream a repeat or something like that. But we will not be live until the new year. So this is the last Graph Guy of the new year. So happy holidays to everyone. Today, we're gonna try to pick up a few pieces that I just didn't get to in our last show. I'll try to talk a little bit more about scaling. Last show did run a little long. We'll see how this one goes. But I want to hit a few other important notes. So last time we talked pretty extensively, excuse me, about the importance of indexes. We did some demonstrations of why indexes were super important in terms of getting good performance, particularly at scale. We talked about making sure you're testing at scale and the dangers of not doing that, and so on. We talked a little bit about modeling as well too, but not all that much. So today I want to go into a few more kind of specific things on that. So let's see if I can remember how to. All right. So I want to talk a little bit about configuration. So here you see I pulled up the Neo4J documentation. We will again be talking about Neo4J. In particular, to talk about how to scale. Obviously, we talked a bit generally last time about some scaling issues. If we really want to be specific, we've got to talk about a specific implementation, and Neo4j is our de facto implementation for labeled property graph. So one of the great things about Neo is you can get up and running and do development with really not having to mess with the configuration at all. I love that. It's super, super simple. And I need simplicity, right? I don't want to have to spend an hour trying to configure my local database or get it running. I want to do my development tasks and focus on that. And Neo lets you do that. And so the downside is that can make us a little bit complacent. Meaning when we go to production, we're used to not having to mess the configuration, and that can lead us into a bad spot where we get out there and go, wow, with a lot of data now, the database just isn't scaling, it's not working. And more often than not, that's our fault for not having configured it. So I've learned this lesson the hard way, excuse me, many, many times. Dog wants to play ball. There we go. So I want to go through some of the things that I've learned in terms of scaling the configuration to point those out to you. So again, here on the Neo webpage, we're in the operations manual, and we're going to pick this configuration file. So if you are unsure, here we are in my Neo4j installation directory. Clearly I'm on Windows. In a Linux-based environment, this might be an opt Neo4j, or I think it's maybe var lib Neo4j. I forget exactly at the moment. But either way, you see there's this conf directory located directly there, and inside of that is a neo4j.conf file. So we'll look at an actual conf file in a moment. But here I just want to point out where this is all documented. So they have a lot of specific settings in here. This one is really important. So Neo4j is a Java-based application. It's written on a JVM language. And as I'm sure you're aware, the JVM is a memory managed system. And so here we're telling it how much memory to put into the database on the JVM heap. This is really important. You'll see that they tell you that it's calculated based on system resources. This is true. It certainly does do that. However, I don't recommend leaving that as is in production on any implementation of any reasonable size. Having had some conversations with some people at Neo4j and some extensive experience with this, the recommendation I'll give you out of the gate is that, assuming a sizable box, I would set the heap size to about 30 or 31 gigabytes. As with most JVM-based applications that are memory intensive, setting the initial heap size and the max heap size, excuse me, just one moment. Pardon me for that. Setting the initial heap size as well as the max heap size to the same value, in this case 31 gigs, can really save you on the performance as you go on, because the JVM, the Java virtual machine, doesn't have to pause to resize that heap as you grow and use resources. So allocate it out of the gate, keep it at that spot. It should be good. So I'm running, for example, a production database that is over 1 terabyte on disk. It is almost 2.5 billion nodes right now, and I'm using a setting of 31 gigabytes. So that's a pretty large database size, obviously, and it's running just great, getting great performance out of it. So, that being said, though, there are other settings that are related to memory that we should talk about. It's not enough just to set this heap size, because what Neo has done over the years is they've done a lot of engineering. And part of this shaky background, my dog is bringing the ball to me under the desk and insisting that I throw it, and that's far less disruptive than him getting really upset and barking about that. So, Neo has worked very hard to take a lot of the memory requirements of the database off of the Java heap into operating system managed memory. And that's super important because, again, as you're aware, if we have to use a lot of memory on the Java virtual machine or any memory managed platform that does garbage collection, then you can get these garbage collection pauses, right, where the entire JVM stops, all the applications stop, while the virtual machine cleans up the garbage. And of course, the larger the memory in the virtual machine, the larger those pauses can be. The pauses are unpredictable, so you don't know when they're going to occur, so you can't really plan for them. So keeping the heap size relatively low, 31 gigs in this case, and allowing the bulk of the database operations to use memory that is managed by the operating system is a huge boost in performance. And Neo's done a fantastic job in their most recent major releases in optimizing for that. So since we're talking about memory, before I jump over that other memory setting that I want to show you, in terms of performance, memory is probably one of the most important factors as you're sizing machines. Like many modern database implementations, Neo wants to store as much of the let's call it active portion of the database that's most recently being used in memory as possible. And of course, the reasons for that are obvious, right? Memory access is orders of magnitude faster than accessing even the fastest solid-state disk still. So, giving it as much memory as you can relative to the amount of data you have in the database or plan to have is super important in terms of sizing your machine and getting good performance. So let's look at, let's see if we can, so I don't want to do it in here. So again, this is talk about the conf files, give some general settings. If you scroll down in here into, I believe it is appendix, and into reference, you can see all the configuration settings. So, well, that last page around talked a bit about the Neo4j conf file, listed a few important things. This is an extensive and exhaustive list of all of the possible parameters you can put into that file. So let me find for you the one that I really care about. So here we go. So we have the off heap max size, right? Let's get rid of that. And as a matter of fact, if we go into this is an actual Neo4j, conf file. Let's make this a little bit bigger, and we look at this. So here's memory settings, right? So you have heap settings, we have page cache settings, transactions, so forth. They have this recommendation, so the amount of memory to use for mapping to store files. A default page cache assumes you're only basically running Neo4j, and they'll set to 50% of the RAM minus the heap size. Really, you want, again, in production, Neo to be the only major thing running on that box, of course, for optimal performance of the operating system. And what you really want to do, again, you want to optimize your memory for the database. So you'll see here, I'm just running this by development box, so I don't need 30 gigs. I have a pretty big desktop, so the amount of memory here for me is not a problem. So I've got that heap and initial size both set to initial and max, rather, both set to 20 gigs. And that's my page cache to 50 gigs. Again, I'm not in production here. In production, what I want to do is I want the sum of these to be the heap and the page cache to be very close to the operating system size, or rather to the total memory size. Now we've got to give some space to the operating system, obviously. So whether you're on Windows or Linux, the amount of space the operating system is going to need obviously will vary. But so, for example, that production instance I told you about, I have about 500 gigs of RAM. I use 30 gigs of RAM, 31 gigs of RAM for my heap, and then I use about 350, I want to say, 350, 360 gigs of RAM for the page cache. That leaves plenty of room for the operating system and things like that, and gives me a really high-performant database system. So that's super important, right? Memory. Make sure the memory is sized right. This is often the biggest thing I'll see when queries aren't running fast at scale and the indexes are set up. It's because you're not properly using your memory. The database is having to go to disk a lot, and that's really going to slow things down. So make sure you look at the memory. Let's look at a couple other things that are in here, and I'll just scroll through this file here. This is the default file. I'm not interested in network configuration in terms of performance at scale here. So we're gonna pass through that. Logging configuration. The reason I point this out in terms of getting the scalability is simply because, again, at large scale, disk size alone can be an issue, right? So Neo is going to do a fair bit of logging, and this is where you are able to go into there and describe what or rather how many logs you should keep, or what logs should even be potentially available. So you can, if you're directly connecting to Neo over HTTP, the REST API, those configurations. GC logging. So GC here stands for garbage collection. You see by default it is off. Generally speaking, you want to keep that off. This is a very, very useful setting if you are having performance problems. It is possible that you're hitting those garbage collection pauses, right? So if you turn this on, then you will get detailed information on when garbage collection is happening, how long those pauses are in the GC log, and that can let you kind of diagnose whether or not that is the issue you're having with certain of your queries. Because it certainly is possible, even with 31 gigs of heap, that you have queries that are taking a massive amount of space on the heap, or some other transaction is doing that, and you're getting these big pauses. This will let you diagnose that, but you don't want it on. Generally speaking, it's going to just take up too much disk space and take up time to do a lot of logging there. Bear in mind, of course, always to set the log rotation sizes, how many to keep, so you don't just end up filling up your disk. Same thing with debug logging. This is a great one. Query logging. So again, maybe things are generally running great, but you've got a couple queries that just aren't running well, or you've got a complex system that are generating queries and something seems to be going slow. Strongly recommend you use query logging to diagnose that. So again, uncomment this. And then you can set these thresholds. The threshold is how long must the query run for before Neo logs it. So if you set it to 0, it's going to log every query. Probably not what you want, unless you're maybe having a lot of problems. You're not quite sure where it's going on, or you're trying to track something else down. In terms of performance, you're probably going to want that set to something reasonable. So I like to have this on in production all of the time, but set as some reasonable threshold. So that threshold obviously is going to be determined based upon your scenario. Sometimes I'll set it 30 seconds because I tend to operate in a lot of systems that do really massive queries against massive database implementations. And when I might be querying 1 billion nodes, I don't expect those to run in sub-second. Some of these are really big, really large analytics, very complicated. I do expect that they're going to run for 10 or 15 or 20 seconds. So I'll set that maybe at 30. So that if something does go significantly long, I can see right away what's actually happening with that. Again, rotation size. Again, you can specify size in kilobytes or meg or gig. How many to keep. By default, if you're doing query logging and you're using parameterized queries, you're going to get the parameters shown there as well. So for the most part, you don't have to worry about that. So let me actually show you a little bit of what a query log looks like, because it can be a bit daunting at first. So this is a query log running as my local system. So I had this set to log everything for the moment, just so I could generate some data. So you're going to see, you can see a lot of, it looks like a lot. You see a lot of things that are sort of formatted like this, right? So you get the date and timestamp of when it's actually happening. You get the log level info. You see the query has started. Every query has an ID associated with it internally that Neo4j will use. This can be used if you need to cancel a running query, terminate one that's been running excessively. It'll show you how long the query took to execute. So these are really fast. These are essentially 0 millisecond queries. I'll tell you where the query came from. These are all come from Bolt sessions. The alternative here would probably be HTTP if I was using the REST interface. Hit it directly. What's the client? This is the Neo browser. Where's the client coming from? So on. So, and then finally, you see the user who's executing the query. You see the database that is, database that is being hit. This is a system query, so I call it dbms.show current user. That actually is against the system database. The user that is executing the query here is Neo4J, and see there are no parameters. It tells you the runtime and so forth. So here's some other queries. None of these are particularly ran for a particularly long time. This one took 8 milliseconds. So you can see here that we ran this query here: call db.labels, yield the label, return all of the labels, some unions on them, and so forth. This took 8 milliseconds. So a lot of information in here, but really, really good if you're having issues in the performance of a query. I do not recommend you use it for audit logging. That is not the appropriate use for that. There are security logs that you can use. And those are probably a better use for audit logging than the query log, right? Because you want to see, if you're doing audit logging, you want to know every user who logged in, you want specific information. Don't use the query log for that. Try to keep the query log really just focused on your performance of your queries. All right. All right. So let's look at a couple of other items here. Let me see. I might need to go to, so this is causal clustering. It's a whole another topic. So here we have transaction log retention policy. There is also, so if I just take the transaction log, I copy that and I go back over here and I for that, so we can see here how large to set the style for the transaction logs and how long to keep them. So the transaction logs are super important to any database. So this is where all the transactions are being written to on disk to help ensure ACID compliant transactions, persistent transactions, things aren't getting corrupted. So really, really important to have a good transaction logs. Generally speaking, I would strongly recommend you not to mess with these unless you have really good experience in doing so, what the consequences can be, as well as perhaps consulting with your local Neo support representative or systems engineer. I will say that you want to make sure that you have enough logs so that if you have to shut the database down and recover, that it can do that gracefully. You certainly don't want to have so many transaction logs that you have a disk space problem. So be aware, these are really important. Generally speaking, I would say do not mess with them. Down here, this is a setting that I've recently had some experience with. They give you a lot of information about it. But basically, in the background, Neo does what's called checkpointing, right? So it's basically writing data to disk to those transaction logs, so that if something happens, there's a crash and things, it can recover from that point. And Neo, very considerately, allows you to specify a limit in IOPS, right? So how many IO operations per second Neo will use, so it's not basically consuming all of your disk bandwidth on your buffers there, doing these checkpointing, right? Because you still have to have bandwidth for writing data to the actual database, reading data from the database, whatever might be going on there in terms of disk-based operations. However, if you're in production and you're running the database with enterprise-grade, high-performant SSDs, which you definitely should be, then you very well are going to want to increase this. So, for example, I run some production databases in Microsoft's Azure environment. They let me, as part of the free monitoring for that, I can see certainly what the maximum and burst IOPS for my disks are, and I can see a real-time chart or historic graph of how many I'm actually using given time. So I like to bring this number up pretty darn close to my maximum IOPS per disk. So if I've got an SSD where I can do 4,000 IOPS per second, I'll bring this right up around 2 to 3,000 and see how that runs. Because I want Neo to be able to run this operation as fast as possible. I want to make sure that those checkpoints are fresh and that they're not slowing anything down. So kind of an advanced feature here. Again, one I've actually just fairly recently discovered. But super helpful in terms of making sure things are as as performant as possible. Something else I want to show you in a little bit of time we have left is there is the ability to now in Neo4j change some of these settings dynamically. Why is that important? So if I change any settings that are in this conf file, these are only going to take effect when I stop Neo4j and then I restart it. That's fine, but often I'm doing something in production, it's running, and I want to know, I want to be able to change something right away while things are going on so I can debug a situation essentially in real time that's happening in production. So I don't want to stop the database and change something to bring it back up. That's problematic. So here, I can change some things dynamically. So here's the operation. Whoopsie. Let's go. If I can use there we go. So here's that call. Let me make this bigger for us. So here I'm basically just asking Neo to give me all of the configurations that are dynamically available, and I'm giving basically their name. In this case, where dynamic is actually true. So so that IOPS limit, that can actually be set dynamically. So if I'm in the I'm looking at things and checkpointing seems to be taking some time, and you can actually see if you look at the Neo4j debug log, it will tell you how long checkpointing is taking. So if that's going to be an issue, and you have lots of IOPS space essentially available on your disk controller, you can bump that up without actually having to restart the database. Taking the database to read only, in case something very bizarre happens or problematic in real time, could be important. Not necessarily for performance, but could be important. You can change the debug log levels again. So to turn those on when you see some more information, you can turn query logs on dynamically. So again, if you didn't turn them on initially, you forgot, or you want to change some of the parameters on that. So that you're showing query parameters, for example, how many query logs to keep, or more likely the threshold. How long does the query have to be running for before you log it? You can do that in real time. So again, maybe something weird is happening. You set the query threshold to be too high and you're not able to see anything happening there, or you set it too low and you're getting way too much debugging information. You can certainly fix it in the conf log, but you can address it immediately while the database is running. So that's a super nice feature to be able to have. And again, so the transaction threshold, all of these things here are available dynamically. So strongly recommend you make use of those as necessary so you don't have to take that database down. One other tip I will give you, this isn't necessarily performance related. Other than that, you probably only see this in large databases. So if you have a really large database, and I'm going to I'm going to particularly address this into the Linux environment because I haven't seen it be a problem in Windows yet, but be aware of it. It could be. If you install Neo as a service, you get a nice shell script that starts the service and so forth. But it comes with a default timeout, right? So if you say Neo, service Neo4j stop, it'll execute the stop script, but it'll only wait, I believe it's like 30 seconds by default for Neo, for that process to stop. And if it doesn't, as is the typical practice with these types of service scripts, it will hard kill the process. That can be problematic. You do not ever want something to hard kill your database. So one of the first things I like to do when I install in production is I like to go in and find that script, find that timeout, and bump it way, way, way up high. 30 minutes, right? Maybe you've just written a whole bunch of data to the database, and it needs a few minutes to make sure all those transaction logs are written, everything's checkpointed and secure so that it is completely solid and good to go. Fine, take your time, stop cleanly so that nothing gets corrupted, so that nothing could possibly go wrong. We'll wait for you. So definitely check that timeout setting. Bump it way the heck up. You do not want to have to force that database into an unclean shutdown, which could force a recovery and a integrity check at startup, which takes time. Make sure you allow your database to do its job, shut down cleanly, and things will go well for you. So that puts us past 12:30. I appreciate everyone joining me. Again, we're going to be off the next 2 weeks. Maybe a rerun coming your way. We'll see. Keep an eye on us for Twitter. Please send me your thoughts, questions, topics. Really want to hear from you. Enjoy your holidays. I'll see you next year. I'm Clark Ritchie, and I'm the Graph Guy. Take care.